Welcome back, everybody. In this lecture, we're going to be looking at another cognitive psychology topic when we examine the area of interest called intelligence. It's important to note, though, before we get into this lecture, that intelligence is sort of a unique topic within the branch of cognitive psychology. Most cognitive psychologists tend to study the basic functions of the mind, assuming that what we find in some participants or even individuals is representative of what we'd see in everybody. They assume that things like attention and memory and language, things that are studied extensively by cognitive psychologists, work the same way for everybody. Intelligence researchers, however, are more focused in on how our ability to do a lot of these cognitive functions differ from person to person. But when we talk about differences, when we talk about how we can actually quantify and study this, we run into an interesting quandary, something that is not very common in cognitive psychology. And it's how to simply define and focus on the topic itself. To appreciate the challenge, I thought we'd start this class off with a little bit of an activity that asks you to think about something that you could use as a means of determining intelligence. Now, I know many of you might automatically go to something like an intelligence test, something we'll be talking about as we progress here, but if you can think outside of the box, find an example or a couple situations that you could piecemeal together to really separate out those that are intelligent from those that are maybe what we would call dull or not intelligent. I'm guessing that you recognize as you're doing this that there's imperfections to it and also challenges with a task that really does ask you to accomplish this. Now, if we were in a traditional in-person class, I'd usually have people after they came up with these activities, as I'm hoping they're kind of percolating in your brain right now. Once we have people do these activities, they then talk with others around them to see if they have similar tests. And what this usually leads to is conversations about some overlaps, some differences, and also the complexity, the different things that really make up this broad idea of intelligence. Because even though we might all have our examples like you see in the photograph here of what maybe indicates a lack of intelligence or a strong amount of intelligence, there's always more complexity to it than just these single situations. And this is what I'm hoping for that we got from this just hypothetical scenario that you are in now, and what we typically get from this activity in the traditional classroom setting, with the recognition that there are lots of different things that could be tied to intelligence, and there's lots of different types of tests we can come up with. Most people want to first, when looking at intelligence closer, then find a way to come up with an overlapping definition of intelligence that we can use to guide some of the research that we want to do in this field. And what most intelligence researchers have agreed upon is that intelligence should sort of be defined as some type of problem solving that relates to kind of better than average or lower than average basic cognitive skills. But even that broad definition of intelligence relating to problem solving and adaptability and learning and other cognitive skills does leave some things out. When we talk about adaptability and learning, we're leaving out memory capacity. We're also leaving out some social aspects of intelligence that most of us tend to attenuate to when talking about what it means to be intelligent and what it means to not be intelligent. Most conversations in the classroom revolve around the difference between what we call book smarts and street smarts. And there's also people that tend to talk about how they know individuals that know the definitions of large numbers of words or can even use a very wide spanning vocabulary when talking about any random topic. And all of this in conjunction with kind of creativity and unusual thought brings us to this place when we try to really harness intelligence, or I guess bottle intelligence, where we really struggle to figure out a good way to even start by defining this area of interest. But nonetheless, people, even if we don't have a 100% clearly agreed upon grasp of what makes intelligence so popular, have been studying for now over a century this topic of intelligence in very interesting, unique ways. And it's shed some really interesting insights into this idea of intelligence, even if there are disagreements about what the implications from certain findings are. One of the things that many people started debating in the early infancy stages of intelligence was how complex the definition of intelligence actually needed to be. One particular researcher that championed things like the correlation coefficient and lots of other statistical analyses was a gentleman named Charles Spearman, who devised all of these different tests that theoretically could potentially find different performances within individuals across these wide-ranging tests. What Spearman kept finding through what he called his psychometric approach was that even though there was some subtle uniqueness to each test he would devise for an individual, overall, the performance of most individuals overlapped pretty dramatically. And Spearman went on to argue that this overlap might be the thing that intelligence researchers can narrow in on, arguing that there might be individual differences on things and experience might matter, but if we can harness or understand your general intelligence, what he called the G factor, we can really be able to compare one person to another. Now, it's also important to note that Spearman's psychometric approach led to some really interesting and controversial statements that we'll talk about a little bit later. This was not necessarily something that resonated with Spearman's research and Spearman's ideas. In fact, when he was pushed to find the source of this G factor, he contended that it wasn't some biologically innate thing, like we'll discuss later, but instead was really probably a byproduct of early childhood exposures, like, say, our health growing up in the first couple years when our brain and mind is first forming. Or it could be about some of the social supports that people get in the really important formative years. Regardless, Spearman's idea of us having just one underlying idea of intelligence has persisted for over 100 years. And even though, as we'll talk about later, many of our newest intelligence tests have diversified in what they look for and try to use to measure intelligence, there is still this underlying concept that we also have an overarching type of intelligence that we should also be able to articulate for each person. But there were some people that were detractors from this concept. One very famous theoretical psychologist was a gentleman named Robert Sternberg, who in his work eventually devised something that he called the triarchic theory of intelligence, and suggested that even if we maybe had some type of a G factor, we actually had three unique types of intelligence that could really give us a better sense of who we were than just one overarching idea. Now, Sternberg's triarchic theory led him in a bunch of different directions as he tried to fine-tune what categories of intelligence actually existed. And what he repeatedly found, much to his frustration and others' frustrations, was that with each tweak and each combination of three different aspects of intelligence, there still existed a fairly robust overlap between all of these. In fact, some went on to argue that Sternberg might have sort of accidentally given more proof to Spearman's research through his inability to really clearly define three separate types of intelligence. But fear not, Sternberg's theories and ideas still persist today and still do resonate with many individuals, and it also led to some really interesting ideas that were really championed by a gentleman in the 1980s named Howard Gardner, who started to propose and promote this idea that he called his theory of multiple intelligences. It was this notion that we didn't just have three different things that were unique within us and could be untethered from each other, but instead we had maybe nearly a dozen things that really made us who we were when it came to this general idea of intelligence. Gardner didn't necessarily reject Spearman's notion that there could be an underlying level of intelligence within all of us. In fact, he sort of embraced the fact that that was probably true. But he also contended that if we really wanted to understand what somebody would be successful at, or how somebody would navigate in a specific situation, that underlying general level of intelligence was not nearly as valuable as maybe a specific aspect of intelligence that pertained to that particular situation. So he'd try to measure things like people's mathematical skills and speech skills and spatial skills. The book actually goes into all of the different intelligences that he looked at. And he would contend that if somebody had X skill or X level of this specific intelligence, maybe they would be better as a blank, an engineer, a doctor, a lawyer, these types of things. And it brought us down a really interesting path when it came to what we could use intelligence research for. It actually countered a lot of the previous ideas about intelligence and how we could use it really as a means of comparison that led one person to feel smarter than another, and instead got us to talk about how each of us might have our strengths and weaknesses that could push us in different directions regardless of how well we did in comparison to others overall. This brings us to a really important component to these ideas of intelligence, and that's how we actually quantify intelligence overall. If we're looking at the history of psychology, more often than not, people cite the work of Sigmund Freud and behaviorists and other individuals in the early 1900s as really the champions of where psychology got its name. But in reality, there was another thing that was probably just as important in the formation of psychology as these big figureheads. And it was the ability to devise these measures of cognitive abilities that we later went on to call intelligence tests. And there have been a large number of different intelligence tests that have been widely distributed throughout the years, but all of them seem to have one underlying goal, and that's to try to find a way to compare the cognitive abilities of one person to another for a multitude of different purposes. We're looking at the first person to ever really devise a standardized, widely distributed intelligence test. We have to go back to the late 1800s and the work of a famous French researcher named Alfred Binet, who in the late 1800s was part of this movement within France to try to find a way to improve the school systems. He essentially was working for the French Ministry of Education in a task that seemed very unenviable and challenging when they asked him and one of his partners, Theodore Simon, to find a way to kind of help the schools become more successful through the kind of ability to detect kids that could be potentially dragging the school down. So Simon and Binet spent nearly a decade devising different tests and different means of analysis so they could actually quantify the mental abilities of very young children, either in the first couple years of school or even prior to them arriving to school. And this test that he devised was fairly rudimentary. He'd ask kids to define specific words or come up with a sentence with a word in it, or be able to identify different parts of the body that he would point to, or retain small sets of numbers or words. Things that, as adults, we should all be able to do fairly easily. But remember, his tests weren't looking to detect kids that were doing great, or to really find ways to compare the subtle differences of the mental abilities of adults. his focus with this test was to find those that were struggling. And to do this, to find a way to detect those that were struggling, he first set out to just standardize the test that he was devising. So after coming up with lots of different ways to measure cognitive abilities, he then tested a couple samples of kids. And initially, he sampled 50 children, 10 per age group. I think he started at age 3, if I recall correctly. So he tested 10 3-year-olds, 10 4-year-olds, 10 5-year-olds. All of these kids were what he considered average, and use their performance on the test as sort of the standard bearer for any subsequent kid that was tested. Now, as his research progressed, as his ideas became more popular, he expanded that samples considerably. But at the heart of his performance and his performance, I guess, but his research and his, I guess, work for the French Ministry of Education, he was trying to find out how a child was performing in comparison to those of both his chronological age and kind of the cohorts that they seemed to align most closely to. So two of the common terms that started to pop up in these Binet-Simon tests were the terms mental age and chronological age. Chronological age dealing with the actual age of the child, and mental age dealing with the performance that the child displayed, and of which age group out of all the different groups that Binet had tested and standardized, their performance was most indicative of. His research, again, just to reiterate, was not very focused on those kids that were doing average or above average. His focus was more on those that were really struggling, so he could do things like he could set up special education programs that could help them thrive or find early interventions that could help them. It's not necessarily something the French Ministry of Education had intended originally, but Binet and Simon were pretty big champions of doing this as it progressed. But it did lead to some interesting ideas, and many people have suggested that even though he didn't necessarily invent the intelligence quotient, figuring out the ratio of a person's mental age to their chronological age became a topic of conversation after the work of Binet and Simon. And it led us down a lot of very controversial and interesting paths in the early 1900s that sort of built off of the work that Binet and Simon had done, even if it wasn't the goal of Binet and Simon to begin with. We're looking at one of the biggest things that started to really evolve from the work of Binet and Simons. It was this push by many people in the late 1800s, early 1900s to find a way to quantify the differences from one person to another. Well, to be more specific, from one group of individuals to another. Many individuals in the late 1800s and early 1900s had started to promote an idea that we call the eugenics debate. This notion that there are specific groups within the population that are essentially superior to others, that they are inherently, through birth, more capable of achieving things in comparison to their peers. And this eugenics debate goes just beyond that and suggests that oftentimes that if there are these individuals that are superior, well, if we want to thrive as a society, we should find ways to ensure that those superior individuals can pass on their genes, and those that are deemed not as superior, we'll say, we should find ways to kind of entice them to not pass on their genes. This obviously led us down a very dark path, especially when people started linking this eugenics movements to specific groups revolving around things like race, national heritage, other things. But it came, oddly enough, from some of the work of Binet and Simon, where they were able to show that certain people were performing at certain levels lower than others. Now, again, I need to reiterate, Binet and Simon were not focusing on specific groups, but this was one of the things that started to come up from the work of Binet and Simon. And another thing that started to come up in conversations as a result of the work of Binet and Simon was how we could better utilize intelligence tests to not only look for those that were struggling, but also look for those that were performing average or significantly better. And this started sort of a quest within the field of cognitive psychology to find a way to devise a much more diversified test that could look at larger spans of age groups and really get, for the very first time, a kind of standard way of comparing people to each other in their cognitive abilities. And eventually led to the publication of a very still widely distributed test today called the Stanford-Binet IQ test, which was actually developed at Stanford by a researcher named Lewis Terman. The Stanford-Binet IQ test is named so not because Binet contributed to it necessarily, but because Terman felt that a lot of the things that Binet had done led to the development of his test, which he argued was sort of a refined, improved upon version of the test that Binet had done with Simon. And he also named it after Stanford because of his love for that particular school. And this test really did try to promote this eugenics ideas that we talked about earlier by trying to look for a wide range of different ages, asking a lot more challenging questions, and trying to show that intellectual abilities across a wide spectrum from person to person could differ dramatically from group to group. Now, to really quantify these differences, he did push this thing that we call the intelligence quotient, which I alluded to earlier is sort of linked to Binet and Simon already in their original work, but it became much more widely distributed as the work of as the work of Terman started to become more mainstream. And again, a lot of the impetus behind this for Terman was not just to make these tests more widely distributed and interesting, start other conversations, was really done in an attempt for him to promote this eugenics movement that became a big thing, not only at Stanford, but many other places across the United States, as there were lots of tensions developing between different groups across the world based on things like religion and race and nationality. Now, this might lead you to think that this idea of intelligence is inherently tied to relatively sad and depressing things. But I want you to understand that the Stanford Binet tests that are used today are not necessarily designed to try to show that one person is superior to another. They're really designed to be able to show individual differences across intellectual abilities, so we could potentially mark somebody as excelling in one particular area versus another, even though we do usually, with that Stanford Binet test, focus in on an overarching level of intelligence within a person. If we're talking about a shift within the focus of intelligence tests, we actually have to go a number of decades after the work of Lewis Terman and look at the work of a very famous historical figure in intelligence research named David Wechsler, who in the mid-1900s started to devise a new refined upon test that was trying to really adjust for a lot of the problems that were identified in the Stanford Binet tests. The first thing that these Wechsler tests did was try to move away from just using the basic IQ formula that had been used in the Stanford Binet tests, and instead focus in on what they called standardized measurement of performance. Now, the standardized measure of performance did away with mental age and chronological age formulas and instead focused in on a person's performance in comparison to their peers of the exact same age. And what this allowed for was the ability for scores within an individual to stay fairly consistent throughout their lifetime. Right? If you're a 4-year-old and you're performing like a 5-year-old, well, your IQ score is going to be very high just by performing 1 year above what you're at. If you're, say, a 10-year-old and you're performing like an 11 or 12-year-old, Oddly enough, your IQ score would have dropped even if you are, say, 2 years ahead of your peers by the time you're 10. Standardization of these intelligence tests that happen through the Wechsler scales controlled for those factors. But it's also important to note that by setting the average of these IQ scores in these tests to 100 and making sure that there was a normal distribution of scores where if you were better than 32% of the population, not better than 32%, but better than 84% of the population, you'd get a score of 115. And if you were better than around 98% of the population, you'd get a score of 130. What we call normalized things. But this approach also kind of forced scores or performances into a normal curve when in reality, when we look at people's performance on these tests, we don't see people performing in terms of the questions from these Wechsler scales in this normalized pattern. Usually when people take these tests, they tend to score fairly well on them. People perform fairly well on them. And what it means is that the subtle difference between somebody earning a 140 and say a 145 could simply be them getting one question wrong at some point while they're taking this test, where the difference between somebody getting, say, a 30 or a 40 on the intelligence test usually is in terms of degrees of multiple questions or multiple components where they're really struggling. Right? The same amount of separation or even less could be much, much different in terms of looking at performance based on this need to kind of force people into this standardized deviation. But it's also important to note that this standardization really does help for statistical purposes. And to help even more and make the tests more viable, one of the things that Wechsler did was he diversified the tests where he had one for children, which was called the WISC, and he also had one for adults, which was called the WAIS. And this allowed for more fine-tuning of the questions, so scores could theoretically be more indicative of intelligence because you didn't need to have really easy or almost impossible questions with each of the tests. You could have ones that could really fine-tune the differences from person to person. Another thing that's important to note with the fine-tuning within these Wechsler scales is these tests were really devised for the very first time to not focus in on just one overarching level of intelligence. Wechsler scales try to test verbal skills, math skills, intelligence abilities in terms of categorization and learning and adaptability. Essentially, the Wechsler scales tried to do away with something that lots of people complained about with the original Stanford Binet tests, and that's some of the cultural and language issues that kind of weighed heavily on people's performances in the tests. And as a result of all of these tweaks and adjustments, more often than not, when a person takes an intelligence test, especially in clinical psychology, they're likely to take one of the Wechsler scales, the WISC or the WAIS, depending on their age, because of how much these have been designed to measure different things that some of the original tests didn't, and how much they've tried to control for some of the cultural issues through the kind of diversification of measures that they've implemented. It's also important to note that even with those diversified tests, some individuals have argued that they don't go quite far enough, and there's potentially lots of language and cultural biases still embedded within even the Wechsler scales. So people have tried to devise tests that focus more on pattern learning or the ability to adjust spatial things in a way where we're not focusing in on kind of Eurocentric things that are linked to intelligence here, but maybe aren't as important in other cultures. A classic example of what's considered a less culturally biased test is one that you see pictured in the right-hand side called the Raven's Progressive Matrices test, where people are shown a series of images that have some type of sequential order tied to them, and people are asked to figure out what's supposed to be in some unidentified box based on the pattern that they're looking at. Now, there are, to be fair, some researchers that have argued that even though this might not seem culturally biased, it is, because there are certain things that revolve around picking up on patterns and being able to identify those things, and essentially rules of how to think that are a component to this. But as a whole, most people have argued that this, in addition to things like the Coe's block design test, which you see listed in the lower left-hand corner, where you're given blocks and have to recreate images, at least allow us to try to diminish some of the cultural and education biases that are inherent within a lot of our more traditional tests for intelligence that we've devised. But even with those things, there has been a raging debate within intelligence research over the last few decades about how we could potentially remove some of the systematic biases within cultures and within groups that many people have argued are just inherent as a result of people developing these tests oftentimes in areas that are usually kind of elevated or have been, I guess, pushed as the markers of intelligence. Now, there's been numerous studies to suggest that these intelligence tests that we devise can be very predictive of certain things, but they're less predictive of things for certain groups. And even though they could be potentially predictive of a large number of things, they're not as predictive as we tend to tout them to be. And all of this, again, has pushed lots of people to continue trying to find ways to devise new tests that are less culturally biased, less problematic when we use these for predictive purposes. And in all honesty, it's still an evolving process that will probably continue to evolve for decades to come. But if we're looking at what lots of people have unfortunately used these intelligence tests for, what we see even today is that a lot of the original ideas of intelligence researchers still persist in lots of our conversations. One of the things that you'll still see often mentioned when it comes to intelligence and cognitive abilities is how what we call heritable these abilities actually are, be it an overall level of intelligence or some subcategory of intelligence that we might want to focus in on. Now, when we get into developmental psychology, we're going to talk about this idea of heritability significantly more, but just for the sake of intelligence, so we can understand it a little bit better, know that when we call something very heritable, we tend to say that that thing is very highly linked to nature or our biology. It suggests if something's very heritable that we are sort of endowed with certain things and we don't have to encounter much for those things to emerge within us. If we say something's not very heritable, what we're saying is the main player in the development of a specific skill is the environment, or what we sometimes call nurture. Now, when we look at intelligence research, it is probably something we would need to mention so we can be fair to lots of people looking at this idea. We do tend to see that intelligence does have some probable genetic components to it, where with sibling studies and other control experiments, we see that the heritability levels and the calculations of these different facets of intelligence tend to be fairly high. But it's also really important to note that why these things are heritable is highly up for debate. One of the areas that's been explored in recent years is this concept of something called evocation, where in essence, if we have a certain look or present ourselves to the population in a specific way, that will in turn, despite what we possess, cause them to treat us in a way that will eventually bring out certain things in us. You might have heard of somebody that looks in a specific way that kind of suggests they're maybe mean or they're very friendly or very innocent. And people treat them in that way because of how they just inherently look. And over time,
that can lead to them actually what we call fulfilling that prophecy that other people have. Another concept that we'll get into when we get into social psychology in a few classes. Well, the thought is when we talk about intelligence and heritability, that evocation is something that we need to consider, and it's something that's very difficult to control for. Another thing that we tend to use is an argument against intelligence being entirely heritable or just the byproduct of genetics is the fact that intelligence scores within kids tend to range wildly from month to month, where a child at age 5 could, say, perform well above average one month, and then a month or two later, after having a couple bad days or weeks, they could go down from well above average to, say, around average. Not that often that kids plummet way down below average when they were performing at a typical level, but that degree of fluctuation in scores, especially at the higher ends, screams to lots of researchers that if intelligence was as heritable as we would expect, well, we shouldn't see that degree of fluctuation and things only leveling off by the time we reach into our early adulthood years. And it highlights to many people that there's probably more to this evocation thing than we give it credit for. And there's also lots of cultural norms that are very tough to tease out and control for when we look at why oftentimes identical twins or people that have similar genetic overlaps tend to score in similar ways across lots of different dimensions of intelligence that we can measure. And if we're looking for any indications that the environment does matter, we do have lots of suggestions that if we do control for certain things, we do see pretty big impacts in performance on these intelligence tests. And most of the research that has focused on intelligence and how environments can impact it have focused on negative shifts that can occur. Numerous studies have shown that groups of individuals that are in what we call mentally impoverished environments, where they're not getting much stimulation, they're not getting much activity, tend to show marked decreases in their abilities to perform well on intelligence tests. There's also numerous studies that have shown that if children, say, miss a year of school because their family's moving or because of health issues, they tend to drop fairly substantially in their ability to perform well on intelligence tests. And it takes them a large amount of time before they have the opportunity to catch up with their peers. And some researchers have even suggested that they might never catch up to their peers because of an extended lapse in time when it came to the traditional educational system that many kids across the world, but in particular in the United States, tend to encounter at a relatively young age. Now, there are some case studies, if you're wondering, that have found that enriched environments, especially very challenging ones, can definitely boost performance on intelligence tests in kids. There have been some questions about some of the ethical quandaries that these things do bring up and whether or not it's usually the parents involved in these case studies had the child's best interest in mind as they really pushed them throughout their early childhood to do everything they could to do as well on intelligence tests as possible. No, if you look into it, that it's not quite as sadistic and horrible as maybe my statements just led you to believe there. But it does highlight how there are factors within the environment that can not only hinder our ability to perform well on these tests, but ones that can enhance it. And in fact, one of the really interesting concepts from statistical analyses of intelligence test performance, called the Flynn effect, focuses in on how environmental things can impact not just specific individuals, but societies as a whole. Now, to clarify, what the Flynn effect is this really interesting phenomenon that we started identifying in the 1970s, 80s, and beyond that showed that to kind of compare individuals across things like the Wechsler scales or for the standard Binet scales that we talked about earlier, what we needed to do to kind of make the tests more usable was actually up the rigor of these standardized tests each sequential year. So if somebody were to say, take one of the very first Wechsler scale tests, and I believe it was the 1930s, what you would see is that individual who, if they were average performance in there, would actually score significantly below an average individual who took another intelligence test, say in the 1990s. And in fact, an average child from 1997 who took a test back from 1932 would probably be considered extremely intelligent just because of the generation that they were being tested in, or I guess because the generation that they were a part of. And then this trend of needing to up the rigor of test questions was actually something that persisted for nearly 6 decades. And it wasn't until the mid 2000s where we started to actually see this trend stop, flatten, and oddly enough, in the 2010s, what we saw for the very first time was this Flynn effect start to reverse a tiny bit. Now, that doesn't mean that, by the time we got to 2020, that all of a sudden kids taking intelligence tests were way back to where we were in 1932. But the small downtick and the constant uptick has led to lots of debates and questions about how the environment and how other factors can explain some of these kind of needs to shift the difficulty of these tests. And all of it again highlights the fact that even if intelligence levels are somewhat heritable, there's a lot of factors at play that do impact a person's performance. And if we truly want to understand what's leading to somebody's cognitive abilities and how they're different from others, we have to understand the whole picture, both maybe some of their backgrounds, but also lots of different factors that led up to where they're at today when it comes to their test performance. And this is, I think, a really good place to sort of end the conversation on this sort of open-ended note, because what it allows us to do is, in the next lecture, explore another area that's very closely related to this idea of comparing mental abilities of one person to another and how these things develop. I don't want to give away too much, but just make sure you're back here for the next lecture when we dissect this, because it will probably give you not only a better understanding of that next topic, but how it very closely relates to this intelligence topic that we were discussing in this lecture. For today, I think this is probably, again, a good spot to stop. So I bid you adieu, and I hope to see many of you soon for our next lecture. Take care all.